In this Stata lecture, I'm going to show you how to use binomial function and the normal functions. In the week 3 lectures, we saw that sometimes we want to be able to find these binomial probabilities. And using the tables is not always going to be the best way, so we need to be able to find these through Stata or some other calculator or some other kind of software. While they may seem like esoteric probabilities, we're going to be thinking of these in terms of a specific problem. So in this example, suppose that we have 3 people. The probability of surviving is 6. What's the probability then that exactly 0 survive, 1 survives, 2 survives, or 3 survives? Here are the binomial functions. I give it the n, the k, the p. So let's look at an example. This particular function says when n is equal to 3 and k is equal to 1 and the probability of survival is equal to 0.6, then what this function will do is to give me a left-hand probability, the probability that 1 or less survives. So what it's going to do is to give me the probability that 1 or 0 survives. It's going to give me the probability of these 2 bars added together. So let me show you how it works in Stata. I just type in display. I type in display binomial 3.1.6 and what that's going and hit enter. And what that's going to do is to give me the results. And here I know what's the probability of 1 or less people surviving if n is equal to 3. If I wanted to copy this into some kind of document like for my homework or to remember it, I could copy it and then copy it as a picture, let's say. So in the lectures, then I showed you what is the code for just one particular bar. What's the probability to find, let's say x is equal to 2. Find the probability that exactly 2 survive in this scenario. How do you do it? You say it's the probability that 2 or less survive minus the probability that 1 or less survive. So it's going to be this left-hand area, this total left-hand area, minus this left-hand area. In Stata, I just type in the commands. So I type in what's the probability that 2 or less minus the probability of 1 or less. And I get the probability of exactly 2. And similarly, I can use these binomial commands to find any kind of binomial probability in Stata by using the left-hand probabilities. So if I want a right-hand probability, I can do 1 minus a left-hand probability. To include specific bars or not include specific bars, then I'm very careful about what values I put in here for k. Next, I'll show you how to use Stata to get normal probabilities. And we see this is very common in many of the things we're going to do, which is we're going to need to be able to go from a z value down here on the z-axis to a probability and vice versa. Given a probability, go back to a z value. So from the lectures I showed you the Stata commands. Now I'm actually going to show you what happens when you type them in and how this is nice. It gives you a log of what you're doing. You can type in any z value, get out any left-hand or cumulative probability, and vice versa. Now, some of these values we already know from the 68, 95, 99.7 rule. For example, if you type in display normal 0, you know that the area to the left-hand area is going to be 0.5. You know this one also from the 68, 95, 99.7 rule, etc. This I showed you in the lectures is how you get a right-hand area, but let's do a few of these. So this one we know already, but I will type it in just to show you. If you say display normal 0, it's expecting a z value in here. Where I type 0, it's expecting a z value. And when I hit enter, it's going to return a left-hand probability, a cumulative probability. And not surprisingly, that's going to be 0.5. If I type display normal 1, it's going to give me the area to the left of 1. And not surprisingly, when I click enter, that's going to be 0.84 because I know that's 68% is in the middle. That means 16% is going to be on each side. So 84% is going to be to the left. If I want a right-hand probability, I just do 1 minus a left-hand probability. So I typed in here 1 minus normal, and I put in the z value, and I get out a right-hand probability there. So I can also use Stata to do the inverse function. So I can give it a probability, and it will output a z value associated with that cumulative probability. So I'll just type in display inverse normal 0.8 0.841, and it gives me back, I expected to give it back 1, right, because those are inverse functions. I see that from above. And there's a slight rounding error because I put in 0.841 instead of all of the decimals. When z is equal to 1, the left-hand probability is 0.84, all of these decimals, and they're inverse. So what we've done here is to cover how to use the several Stata functions, the binomial functions, and two functions involving the normal probabilities.